Good morning and welcome to the 18th Annual World Congress for Brain Mapping and Therapeutics. We are starting our second day with Professor Deepak Chopra, and we are going to have a fantastic keynote and also a panel on consciousness. So, Professor Deepak Chopra.
Good morning. So I'm going to speak for half an hour, and then I'm going to invite my two colleagues, physicist Menas Kafatos, he's an astrophysicist, and Professor Chetan Prakash, who's a mathematician. What we're going to talk about this morning is actually, I think, a very important question today in science, and how the brain and understanding the brain mapping process can give us a deeper experience into the nature of reality. Could you start the clock for me so I can monitor my time, please? So, if you Google the following question, and you can do it right now if you want or at your convenience, the question is, what are the 125 open questions in science? And the first question is, what is the universe made of? And you would think, well, it's obvious what the universe is made of. Atoms, force fields, particles, gravity. But there's a problem with that, and I'll tell you what that problem is. The problem with this question, which is at the moment an open question, is that 70% of the universe is thought to be something called dark energy, which is anti-gravity, an anti-gravity force. It's not the usual, I think, Menas might correct me, not the usual energy we think of as E is equal to mc squared. Whatever it is, it's also called the cosmological constant. It is responsible, apparently, for the expansion of the space between galaxies. So right now, as I'm speaking to you, the space between galaxies is expanding faster than the speed of light. The cosmic horizon, which is the farthest the universe has extended, presumably, is about 47 billion light years away from us. 47 billion light years away from us. And galaxies are moving across that, and as they're moving across that, space-time is also expanding. That leaves about 30% of the universe remaining, of which about 26% is another mysterious entity called dark matter. Dark matter is so called because it's invisible. And the reason it's invisible is that it's not atomic. So we are made of atoms. The human brain is also made of atoms. And we can only interact with atoms. That means light. And dark matter presumably is not atomic, although there are suggestions that it's made of some particle. It's called a weakly interacting massive particle, WIMP, W-I-M-P. Nobody's observed these WIMPs, but science, of course, is relentless, and lots of experiments are being done underground to see if weakly interactive massive particles exist or not. Bottom line is, we don't know what dark matter is. It's most of the gravity in the universe is actually from invisible so-called matter. Why do we even call it matter? Because presumably it's bends space-time in the same way as regular matter and is responsible for, as I said, most of the gravity in the universe. Without that gravity, our planet would spiral off and disappear and get lost in intergalactic space, and there would be havoc in the universe. So 4% of the universe is atomic. Of that, 99.999% is invisible interstellar dust. Again, thought to be hydrogen and helium, but it's invisible. So the visible universe, which is 2 trillion galaxies. We live in the Milky Way galaxy, 2 trillion galaxies. You can look it up. I am not making this up. 700 sextillion stars and uncountable planets, presumably according to current calculations, 40 billion possible habitable planets just in the Milky Way galaxy. The visible universe is 0.01% of what exists. 0.01%. The rest is invisible, mostly unknown, not mostly unknown, but possibly unknowable. Because how do you interact with stuff that's not atomic? And as I said, we and the human brain are made of atoms. So what's the universe made of? Bottom line, I think everyone will agree, with the experts that I'm going to call on the panel, it's made of nothing. So there's a phrase in physics these days, the universe is a free lunch. It's made of nothing. So that leads to the second open question in science. What is the biological basis of consciousness? Because without consciousness, we wouldn't know that we exist or the universe exists. You have to be a conscious being. Actually, you have to be a conscious human being in order to use the word universe. No other animal has the cognitive or perceptual or imaginative or mathematical capacities to even address this question. So what is the biological basis of consciousness? And it is presumed these days in science, particularly in neuroscience, that consciousness is a product of the human brain. Our brain produces consciousness. And therefore you have to define consciousness. And I think, I've been to many conferences where it takes weeks and weeks for people even to talk about consciousness and what does it mean. So here's a few definitions of consciousness, just so we are on the same page. Consciousness, the knowing element in every experience. We know that we are having this experience. That is what consciousness is, the knowing element in every experience. Without consciousness, there's no knowledge of anything, including the human brain. So current science says consciousness is a product of the brain. So consciousness is a product of the brain, and then consciousness knows the brain. The product knows its source. It's like saying a dream is the cause of a dream. And so this is called the hard problem of consciousness. If the universe is made of nothing, why does it look like this? Why do we experience colors and shapes and forms and sounds and tastes and textures and thoughts and feelings and imagination? Of course, if you look at the brain with a PET scan or any other technology, you'll see what are called neural correlates of consciousness. I'd rather call them neural correlates of experience. They're not necessarily neural correlates of consciousness, because there's lots of experience we have that we are not aware of, including dreams and sleep and so on. So when you look at the brain with any experience, you can map the brain. Today we can map the brain, we are at the brain mapping society, for every experience. But what you see is neurochemistry, you see electrochemistry. That doesn't explain this experience you're having right now. So you're listening to sound. Where is the sound? There's no sound in the physical universe. There's no sound in your brain, but you're having the experience of sound. You're seeing shapes, colors, and forms. There's no color in the brain. There's no color in the physical world. Where is the color? How does the brain produce thought, feelings, emotions? Neural correlates, electrochemistry. This is the hard problem. And These are the two most important questions in science. If we could answer these questions, we will change science. We will change the way we do science, including brain science. So, over thousands of years, people have thought of the nature of the universe in the following ways. This is the most original way that human beings have thought of the universe. We call it the divine universe. God created the universe as the source and origin of life, and also of our mind. And I like this slide, actually. If you look at the Sistine Chapel, that's what God is doing, bestowing humans a brain, and a human brain. And you see the Sistine Chapel there. If you actually look at it very carefully, Michelangelo had a brilliant idea. He shaped it like a human brain. This paradigm existed till Isaac Newton about 500 years ago, when Newton said, no, there are laws, and these are known through human reason and logic. And so, along with other great luminaries, we actually became aware about 500 years ago, or less, of what we call the classic universe, governed by the laws of motion, universal gravitation, Kepler's laws of planetary motion. Newton explained Kepler's laws and the motion of objects on Earth and celestial bodies, and from this we draw the laws of thermodynamics as well. But then in 1905, Albert Einstein published the special theory of relativity. Every schoolboy now hears of the formula, E is equal to mc squared, the constancy of the speed of light, and the speed limit of light as a constant for all frames of reference. And then in 1915, Einstein also published the general theory of relativity, the geometric relativity of gravitation, and gave a unified description of gravity as a geometric property of space-time. And from this we drew black holes, which now are a given, the gravitational time delay, so time slows down as gravity is increased, and in the singularity, time stops. As you can see, Albert Einstein's two theories brought the observer into all calculations. However, nobody defined the observer. Right now, you are an observer. You're observing me. You're also observing yourself. If you want to, you can observe your body. If you want to, you can observe your thoughts. If you want to, you can observe your emotions. If you want to, you can observe your imagination. You create an image. I'll ask you right now, create an image in your mind of the Empire State Building. Where's the image? It's not in your brain, but you're seeing an image. Okay? If I asked you right now, think of John Lennon singing the song Imagine. Can you hear it? Where is it being heard? If I look inside your brain, there's no sound, but you're hearing it, right? You're hearing a subtle sound. If I look inside your brain, there's no image. Where is it? And the only thing we can say is it's in consciousness. Okay, so where is this consciousness? Well, we can't see it. Why can't we see it? Because it doesn't have a form. It's invisible. And if it was visible, you'd be able to see it. But this invisible, whatever it is doing the seeing, actually. And it is doing the seeing of everything you experience, including a mathematical formula, or including any ideas you have. So, the general theory of relativity is derived from a philosophy in science called naive realism. And this is not a condescending term, by the way. Naive realism is also called scientific realism. And science is based on naive realism. Naive realism means that the physical universe would exist exactly as it is perceived by the five human senses, even though there would be no human beings to see it. Einstein was a naive realist. He said the moon would still exist if no one was looking at it. But of course he was talking about the human moon, not a dolphin moon or the moon of a horseshoe crab, which has no access to light and yet comes to the surface of the ocean on a full moon night to mate, because it has a different experience of the moon. So what is the moon to what? What is the moon to an insect with 100 eyes? What is the moon to a horseshoe crab that lives in the depths of the ocean? What is the moon to a chameleon whose eyeballs swivel on 2 different axes? You can't even remotely imagine what it would look like, or this room would look like, to another species, although there's some cross-leakage of experience. If you have a dog or a cat, you have some experience, and you even have a relationship with that animal, but you have no idea what they're experiencing. So naive realism says that the universe exists exactly as you and I perceive it, not any other species. It's a very narcissistic idea, by the way, and doesn't make any sense. Okay? So scientific realism, naive realism are the same thing. They're based on 3 fundamental flaws in logic. Number 1, that the universe is exactly as humans perceive it with their brain. And we don't even know how the brain converts electromagnetic energy into experience. We don't know. That's the hard problem, number 1. But number 2, the universe would continue to exist as we perceive it, even if we were not there. It's illogical. Scientific realism is based on illogical reasoning. Number 1. Naive realism. Number 2, subject-object split, dual thinking. Me and the universe, when me is also an activity of the universe. How can you step out of the universe? You are a process in the same way as a star or a galaxy or an atom or a molecule as a force field. So there's no subject-object split, but we need it to do science. You need an observer, which leads to the third problem with scientific realism, which is that there's an embodied observer. There's somebody inside your body looking at the world and looking at yourself and looking at your brain on a CAT scan. Well, nobody's found this person. There's no little Deepak sitting in the brain looking at the world through these eyes. Where is the observer? Can't be found. So lots of problems with our current science. How do we address it? The relativistic universe is much more, we would say, dynamic. Space-time, matter are all interdependent. And Einstein became a reluctant participant with this new universe, which actually went beyond the relativistic universe. We call it the quantum universe. So Einstein was a participant in this, a reluctant participant. There were other luminaries that you see over there, Niels Bohr, Schrödinger, Max Planck, Paul Dirac, many others, who gave us a new idea about the universe, which actually came from mathematics. So, as did relativity. So, the quantum universe deals with the behavior of electrons and particles and other elementary particles, fundamental processes, which are very ambiguous. Is it wave? Is it particle? The visible universe is made of atoms, but atoms are made of particles, and when they're not being observed, they are waves. So waves don't occupy space-time, presumably, because they're waves of possibility in mathematical space. And yet particles appear in space-time. So this has been a bone of contention. What is the wave function which provides information and the probability amplitudes and positions of particles? And so this gave rise to an idea of non-locality as well, that fundamental reality might be prior or beyond space-time. If you go on Wikipedia, you'll see about 30 interpretations of quantum mechanics. And right now, the most popular interpretation of quantum mechanics is what is called the multiverse theory. There are infinite universes, there are infinite versions of you and me, and superstring theory supports that, but it's all mathematical, and that's the model right now. The most popular model is multiverse. If you want to read about it, Caltech professor Sean Carroll has written an interesting book called Something Deeply Hidden, and he favors infinite universes and infinite versions of you and me. The problem is they're all in different dimensions of space-time, so you'll never get to meet the other infinite versions of you that exist in these dimensions. Until recently, the most popular interpretation of quantum mechanics was called the Copenhagen interpretation, named after the pioneers who said you need an observer to collapse the wave function. But again, everybody's talking about an embodied observer, and an embodied observer cannot be found through all the technology that we have. Right now, I can radio label a sugar molecule, put it in your bloodstream, track a thought. So everything can be tracked in the brain, but all that you can track is electrochemical activity. You cannot say where the observer is or where the whole thing is being processed. So this is where we are. The quantum universe has led to many mathematical guessing games. 35 interpretations: eternal inflation, superstring, many worlds, multiverse, M theory. So all leading to a very interesting time in our science that we do not actually understand the nature of what we call reality. We do not understand the nature of what we call reality. 2 trillion galaxies, 700 sextillion stars, uncountable trillions of planets, 40 billion possible habitable planets in the Milky Way galaxy, less than 0.01% of what exists there. And even that 0.01% turns into nothing when it's not being observed. So what's going on? This is what we know today. This is the state of our current science. So today we are here to propose to you an alternative explanation of science, that the universe is a human construct, that there is no universe, that what we call the universe is the interpretation of sensations. Please listen very carefully. What we call the universe is the interpretation of sensations, which includes sense perceptions, images, feelings, and thoughts, period. The universe, the physical body, and the mind are interpretations in human consciousness for human sensations: sound, touch, sight, taste, smell, human sensations as we perceive them. That's it. If you want an acronym, SIFT, S-I-F-T. Now what is the mind? The mind is a relational and embodied process that regulates the flow of energy and information in an ecosystem of sentient beings, not just humans, animals, plants, anything that responds to a stimulus with an activity, anything. That's what we experience: sensory information, motor activity, and both are sensations. In between, we have an interpretation. We call it mind, body, and universe. Therefore, there is only consciousness and its excitations. The excitations in ancient wisdom traditions of the East, in China, in Sanskrit, are called vrittis. Vrittis are excitations of consciousness that appear as on the screen of consciousness as sensations, images, feelings, and thoughts. And then humans have a story around that. We call it mind, body, and the physical world. But if we understand this thoroughly and totally and completely, then we have a new science. And that science does not believe in object-subject split. Object and subject are made of the same substance. And the substance is not matter. Matter is not the ontological primitive of the universe. The substance is not space-time. The substance is not gravity. Those are human constructs for modes of knowing and experience in consciousness. And even the brain is a human construct for modes of knowing and experience in consciousness. How do you know there's a brain? You see it on a dissection table or on a CAT scan or on whatever. That's how you know you have a brain. And the brain can't see itself, the eyes can't see themselves, the ears can't hear themselves, and these are actually instruments of observation. Your sensory apparatus and your entire body is an instrument of observation. There's a species-specific mode of observing, but the observer is formless, has no form, and therefore is infinite. Now, if you go to religious traditions, they'll call it God, Allah, Brahman. Today, I offer you an alternative definition. Acausal, which means without cause, non-local, beyond space and time, quantum mechanical interrelatedness, entanglement. But entanglement not only of energy, space and time, entanglement of qualia. Qualia are qualities of awareness. Color is a qualia. Actually, visually, all you see is color and shape and form, and the three are related. This is a shape, form, and color that differentiates this from that or this. Call it a desk is a human construct. You could call it a tree. You could call it wood. You could call it atoms and particles and gravity and space-time. Those are constructs. Raw experience is qualia, qualities of experience. Color, shape, form, sound, touch, sight, taste, smell, thoughts, feelings, imagination, mathematics. These are human constructs for modes of knowing and experience in human consciousness. So everyday reality is a human construct. In other words, my dear friends, we are already in a simulation. This is a simulation. Your body is a simulation. Your mind is part of the simulation. We are living in a VR world. And today our technology is helping us extend that through augmented reality, virtual dreamscapes. If you sit in a VR room and you watch a movie, your blood pressure goes up if the movie is horrifying, right? How does your blood pressure go up if you're watching something that's just on the screen? It has nothing to do with reality. The reason your blood pressure goes up is you, your brain, and your body, and what's on the screen is the same stuff. And it's not the same stuff as we define stuff, because it's non-stuff. It's formless. It has no location in space-time. Where is this being processed, this experience? Beyond space-time. But we are having the experience of space-time. If we get this totally, then we have a new science in consciousness. We look at consciousness as fundamental reality, self-organizing, self-regulating, self-evolving into modes of knowing and experience, and the mode of knowing and experience that we call human mode of knowing and experience, because we are a species of consciousness, differentiated, just like a stem cell differentiates into different organs of the body. Consciousness differentiates into species of consciousness, all experiencing their own universe. And humans, by giving definitions and constructs and language and math to those experiences, you and I have created the universe. This is the basis of a book that I wrote with astrophysicists, climate change expert, mathematician, trained with Morrison at MIT, Professor Menas Kafatos. Please join me on the stage. And the book is You Are the Universe. It's been around for 3 years, gradually catching the attention of scientists. And Chetan Prakash, Professor Chetan Prakash, University of California, mathematician, who has the math to hopefully agree with what I'm saying today. But if we embrace this new science, then we will extend our capacities for imagination, for insight, for intuition, for creativity, and actually, we will be on the next adventure in science, how to construct a new universe, how to construct a new brain, how to construct a new body. Now, this sounds very outlandish. Please welcome Professor Chetan Prakash and Professor Menas Kafatos. So we can all sit comfortably. You can sit here.
Okay.
Okay. So, Menas, you're an astrophysicist. You're a climate change expert. You trained with Morrison, and you knew all these great people. Unfortunately, they also made the atomic bomb. Your professors that you trained with. But you've studied the universe. What's it made of?
That's a very good question, Deepak. Thank you, by the way, for the invitation to the organizers, and appreciate being here. So Deepak took us in half an hour in a dazzling trip of asking some old questions which are still, in a way, remain unanswerable. Because if the universe is made of nothingness, nothing, then what is the one that is even making the statement? So this is what Deepak said, this is the so-called hard problem of science. I will actually perhaps say that maybe the hard problem is the easy problem. It really depends on your point of view. But before we get to the nitty-gritty of exploring the nature of reality, if the universe is quantum, which means really that it's made up of bits of energy, okay? Then we have to say what energy is. Energy, when we talk about in everyday life, it means really moving about. I have energy, I have a lot of energy, I have little energy. But if energy is the underlying part of what we call matter, and of course, as Deepak said, by Einstein, is equal to mc squared, energy and matter are interchangeable, then the underlying stuff of both must be something that is beyond energy and matter. And this is, of course, what perhaps we say it's the hard problem, which you cannot take the observer out of the picture. Okay. We imagine we can take the observer out of the picture, but it's an imaginary trip in the sense that, okay, the universe is out there, I'm the observer, but then when we interact with the universe, or when we interact with other beings, of course, it's very obvious that they and I are in a continuous interchangeable relationship. So perhaps to step back and look at the whole thing is to look at three fundamental principles, and I call them fundamental because everything, including the quantum universe and cosmology, is based on these three aspects of reality. The first one is the so-called complementarity, which really says something is and something is not. Sounds a little bit outlandish, but the existence and non-existence, the continuous interaction between the two. The second one is the principle of that we can know, that it's possible to know, and we call that universality. Science would not be possible if we did not believe that somehow knowledge is not just in one bit of part of the universe, but it is really universal. The third one is interactivity. So these three principles, complementarity, universality, and interactivity, are actually the guiding, if you like, principles on which, the scaffolding, if I can call it that way, on which the entire experience of the universe rests upon. Okay, so, but it comes again back down to the fundamental issue. Who is observing? Who is behind all of this? And of course, if you ask me, if you ask Deepak, if you ask Chetan, then we would probably all three of us would say, well, who are all three of us are observers. But then, who is not observing? So the issue of observation and not observation is this question of dichotomy. Where do you draw the boundary? So von Neumann, a great physicist and also quantum, perhaps the founder of modern computer science and computing technologies that we have at our disposal, posed that question: where is the boundary? Where do you go from the what we view around as the sensory produced levels of reality to the fundamental underlying stuff, whatever that stuff is? And the answer is, you cannot draw the boundary. If you cannot draw the boundary, then I would submit to you that there's no boundary, which then comes back to what Deepak was saying just a little while ago, the issue of what is the universe. If there's no boundary, then the universe and I, the so-called I, the perceiving I, must fundamentally be the same. And that is really the point of our book. Thank you.
Okay, so Menas brought three principles right now to our attention. Complementarity, creative interactivity, and universality. And also the idea that the universe doesn't have boundaries. I think that John Wheeler had a famous expression, the boundary of a boundary doesn't exist. Something like that. But as you saw in my slides, from Isaac Newton until today, everything that science has given us, fundamental science, has been through what we call the gift of mathematics. What is mathematics? Where does mathematics exist? Why is it so unreasonably effective in predicting outcomes of experiments? Now, today, even biology, you can study through algorithms. Every reaction in your body can be translated into mathematical algorithms. Everything, other than imagination or creativity at the moment. Insight, intuition, because those are also expressions. Mathematics is an expression in the same way of consciousness as the universe is. So Chetan Prakash works with eminent physicists. So, Chetan, why is mathematics? What is mathematics? Why do we need math to do science? And where is mathematics?
The short answer is I don't know.
But you're a mathematician.
Yeah, that's the thing about I do mathematics, and I think we all do mathematics, actually. Mathematics exists within consciousness. There's no doubt about that. And in fact, it was interesting that you said that mathematics has, at this stage, has achieved sufficient sophistication that it can be used even in areas like biology, sociology, in describing, at least in modeling, all sorts of areas of human experience. But it doesn't really, it hasn't got to the point of being able to describe intuition or awareness, right? And without awareness and intuition, there would be no mathematics, in fact. Still, I think it's extremely useful this is a great question. Where is mathematics? And why is it so unreasonably effective in modern science? My own point of view, which may evolve further, is that mathematics exists, in a sense, it exists on that same interface that you've been talking about in a very inspiring way earlier on, that the universe for us is really, what is the universe? It's an interface for each one of us. It's our view of things. It's almost, in some sense, a projection from us into our awareness. It's a projection of our awareness. But mathematics, I think, has a special place. It's both special and it's also very limited. I think that you could describe mathematics as that aspect of consciousness which is almost like its skeleton or its scaffolding. There are aspects of our experience which can be described in very abstract terms without losing too much meaning. In other words, the meaning is in the abstraction itself. And that part of our consciousness, I think, is mathematics. Mathematics is not fixed. It's continuously evolving. In fact, it's very interesting that the great logician Kurt Gödel talked about, produced some theorems which showed an astonishing fact, which is that any kind of mathematics has within it propositions which may be true, but which cannot be proved from within it. So that itself tells you something about even the most, shall I say, skeletal, purely abstract aspect of our consciousness is endless. Okay, so why is it so useful? I think because it is scaffolding in some sense. It does describe things at a very, very abstract level. And so if you want to sort of come away from the incredible richness of our experiences and sort of bring your attention down to very, very specific things, as physicists do, for example. You have a very clear experiment in a lab which is completely described and prescribed, and you're only looking at certain variables and certain dynamical systems, then mathematics is naturally going to be effective there because you've taken away a huge amount of the richness of our experience. So that's my current view about mathematics. I think that it is somewhat, it probably has a slightly different ontological status in the sense that it seems like it is the way we think. It's sort of the map of the way we see things. But it's just a map, it's not the territory. So I don't know if that's quite what you believe yourself.
Beautiful statement. in conclusion, it's the map, it's not the territory. And I would suggest to you, since we are at the Brain Mapping Society, that the brain itself is the map. It's not the territory. The brain is the symbolic map for navigating the territory, which we call human experience. So given what you've said, and I'm going to come back to you with Gödel's theorem and more, because you've gone beyond Gödel's theorem, I believe. Minas, is math made of the same stuff as the brain is made of, or anything else made of, a fluctuation in consciousness?
So the question is, what is the brain? Well, we know that the brain is made up of trillions of cells and of incredible complexity. Of course, we're here with experts in terms of the mapping the brain. But just if you map the brain, that still does not give an answer to what is conscious awareness. So somehow awareness comes out of complexity. So, you know, if you have a very complex system, eventually it's going to become conscious or self-aware. We don't really know that. How do we know that? So going back to some of the old traditions, you know, the old statements from the dawn of time, so to speak, of human history, a self-aware being that ponders, looks at the universe, and finds, yes, look, like, by the way, the stars that we see with our naked eyes, there are only a few thousand, whereas, of course, as Deepak said, there's roughly 2 trillion galaxies hurling away from each other as the universe is expanding. So we see a very, very tiny number of stars. And we ponder, we look back with our own beginning, going back to our early childhood, so to speak. And we come at the point we say, well, you know, I don't remember beyond that. I don't remember when I was very little. And yet we have this self-awareness. So what is constant in our own experience is this self-awareness, which is always the same. It's beyond the senses. The senses give us what Deepak called the experiences of the qualia, but those are based on a particular species, which is Homo sapiens, which now we know it's probably not more than 250,000 years old, so to speak, and survive after, from many other species that went down to the nothingness of existence. So it comes back again to the question, who is the observer? And mathematics is very useful because it allows us to communicate with each other. It's a universe in the sense that all conscious beings, whatever that means in the universe, will communicate with mathematics. Certainly they will not communicate in English or in Greek or in maybe not even in Sanskrit or Chinese, but mathematics is a way to put formal aspects. And yet, consciousness, as we are discussing here, is the formless beyond form. Formless beyond the form. So this is actually the Socratic statement of one thing I know is I know no thing. If we know nothing, then it is everything.
Beautiful. If we know nothing, then we know everything. Because every bit of knowledge is so specific, it excludes everything else. So with that, Chetan, I've heard you say, and I've heard Don say, that space-time is doomed. You just mentioned Gödel's theorem, which says there are theorems that are true but can't be proved. This is leading us to a new frontier. Is space-time also a human construct. And where is the new math leading us in terms of evolutionary biology and mathematics? We have less than 10 minutes, so if you can give the answer in 5 minutes, we can come to a good conclusion, hopefully. That will set people thinking a little bit.
Thank you. Yeah, I'll try to give it in 5 minutes, but then it'd have to be all in mathematics. But okay, so there are three pillars of Western science, or modern science, really: relativity, quantum mechanics, which Menas is an expert on, and evolution. Evolution is sort of the foundational pillar of biological science. And so, very briefly, Don Hoffman at UCI and I and some other colleagues wanted to see whether we can use evolutionary science, or I should say evolutionary mathematics, to explore this question. And our point of view was very simple. We want to talk to physicalists, and we want to say, okay, if we grant you a naive physicalism, or even not so naive physicalism, if we grant you the fact that there is an objective universe out there which exists independently of any observation, and if we grant you the fact of evolution by natural selection, which everybody believes in, let's see what the consequences of those are. And so we did a mathematical study using evolutionary game theory, which is pretty much unassailable in the sense that nobody has assailed it that I know of, including it is ontologically neutral. People who are atheists, people who are religious people who are Buddhists, all of us agree that the mathematics of it, at least, is something that we can rely on. So we used evolutionary game theory to pose the following question. If you have two types of being, say, one which observes the truth, one which observes objective reality, and the other type of being or entity observes only that which is fit for its own species. In other words, it responds only to fitness, not necessarily to any objective reality. And we run a simulation in which, or we run a game in which they interact with each other, what's going to happen? So this is an evolutionary game in which they're competing with each other for the same resources, one of which, one of the species, if you like, observes objective reality, and the other one only observes the fitness. And it turned out that we can prove mathematical theorems that show that the species that observes fitness drives the species that observes truth to extinction. Now, this contradicts the belief, the standard belief amongst all cognitive scientists and many biologists that our species has evolved through natural selection in order to observe the truth, observe objective reality more and more closely. In fact, every textbook on perception says that we've evolved to perceive things accurately. Veridically is the technical term. But the mathematics says otherwise. Okay? It's very counterintuitive, though some biologists tell me, well, fitness, of course. So, I mean, we could get into the whole question of fitness. We don't have the time here, but everybody agrees that there is such a thing. Fitness is not just a function of objective reality if you agree that it exists, but it's also a function of my species. It's a function of my action class. It's a function of my environment, the situation I'm in. It's a very, very complicated thing. And so what this leads us to believe, and there's a whole sequence, there's 7 theorems which show that you can take structures in reality or in objective reality, which we're granting for the moment, and you can ask, will a species that recognizes those structures survive? And the answer every time is no. It's, you know, that's the fact. That's the mathematics of it. That suggests that we should think about things the way Deepak is talking about it.
So the theorem again, fitness beats truth. Truth leads to extinction. fitness is the criterion for evolution. What is being raised here is so drastically different from what we call science today. Random mutations and natural selection, brilliant idea, but may be wrong. That's the history of science. Everything we've done ultimately is falsified and new theories emerge, which are also probably wrong. That's how science is done. But what we raise here is our important questions. If we can answer and pursue these questions and shift from matter, space-time, energy and information as the ontological primitive to consciousness as the ontological primitive, and energy, information, matter as symbolic representations of modes of experience and knowing, we will have to readdress every issue that humans have pondered upon. Birth, is that a construct? Death, is that a construct? Biology, is that a construct? Are we living in a simulation? Is this a VR reality? If we put the math together, we have a new frontier in science, new technologies that will emerge, and actually ways to map the brain where we can actually observe what the brain is doing as we are having an experience, and then direct the brain to have new experiences. Because we are not the brain, we are not the universe. The brain, the universe, the body and mind are conceived, constructed, governed, and come into existence in this mysterious self that we call consciousness, that has no location in space or in time. Would Menas agree, Chetan agree, that if we adopt a new way of looking, we will have emergent technologies? Just one sentence, yes, no. Do you think a new science could lead to better technology, more humane understanding of biology, and better treatment modalities?
Yes, we have though to give up the old ways.
Chetan, implications for technology.
Yes, I think that with this new point of view, the technology will expand, and it will expand in a more compassionate way.
Thank you very much, and thank you for listening to this conversation.